Hello guys, welcome to another video from Computer channel. In this video, we're gonna continue our playlist in coding interview and solve another famous question that you may see in your interview that we call it linked list cycle. And this question is about we want to recognize that there is any cycle in our linked list or not. And yes, that's it guys, let's solve it together. Okay guys, as you can see here, this is the question that we have, linked list cycle. Given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pos is used to denote the index of the nodes that tail next pointer is connected to. Note that pos is not passed as a parameter. Return the true if there is a cycle in the linked list, otherwise return false. For example, this is the example number 1. Our input is 3, 2, 0 and -4 and the pos is equal to 1. So it means that if we reach the end of our linked list, we will back to the first pos that is equal to 2. And our output here is true because we have this cycle here. The explanation is that there is a cycle in the linked list where the tail connected to the first node or 0 indexed. And for example number 2, again our output must be true because we have this actually cycle here. And yes, and for the final example, the output here is equal to false because as you can see here, in this question, we have only one node and there is no cycle on it. So the question and the answer must be false. And actually, this is actually our constraint that we have here. The number of nodes is in the list in the range of 0 until this number here. And we have actually this interval for our node value. And actually, we have a follow-up here. Can you solve it using actually a space complexity of order of 1? And the answer is yes, we can solve it. And actually this is the best and optimized idea that you can use for solving this question. And the idea is that you must use from 2 pointer for solving this question. One pointer that we call it a slower actually, that we have to move it with only actually one pointer, so the slower must become equal to a slower dot next. And we have another actually variable here that is, we call it faster, and faster must become equal to faster dot next actually like this. So actually we move slower actually with one pointer and we move faster with 2 pointer, and this is how we want to solve this question. For example, if you can see this example that we have here, that we have 3, 2, 0 and -4. If you check this question here, if we actually define our variables slower and faster and keep moving these variables slower with 1 bit and faster with actually 2 places here, we know we can prove that with some steps, some constraints, a number of steps, that we can reach the point that slower will become equal to faster, and this will show us that we have a cycle in our linked list. But how we can prove it? For example, assume that the point that slower actually entered the cycle. We know that faster actually entered our cycle earlier than a slower pointer that we have here. So from the point that a slower actually entered our cycle here, for example, assume that this is the point that a slower actually entered our cycle here. And after this part, you can actually calculate the distance between a slower and faster here. For example, assume that there is 3 point, or better I say, there is 3 node distance between a slower and faster. And assume that the whole cycle has, or better I say, contain n nodes in it. So So the distance between faster and slower from this point of view is equal to n minus 3, and from this part is equal to 3. We know that actually faster move actually 2 bit for any step that actually we go on. So for any step that we have here, first let me actually move the slower pointer first. So when we move this slower pointer here, our distance will actually increase with one value. But after that, we must move the faster pointer here with 2 places. So we must add a minus here, minus of 2. So our calculation here will become equal to actually n minus 4. And if we keep actually doing this work again and again and again, finally our distance will become equal to 0 for, because in any steps that actually we take, our distance actually from this point of view will become our last distance minus 1, and after actually actually finite step that goes on, our faster pointer will become equal to our slower pointer. And this is the idea that we want to use to solve this question here. So let's back to our question here. First, we must define 2 variables here. First one is a slower, and after that we must define the faster, and both of them are equal to head. And we know that the faster pointer is actually faster than the slower pointer. So if we don't have any cycle in our linked list, the faster pointer will become equal to none earlier than a slower pointer. So we write a while loop here while we have faster pointer in our variable and it is not equal to none, because we know that when we reach the end of our linked list, the next node if we want to reach is equal to none. So while we have faster, we can actually move our slower pointer with one place, slower dot next. And for faster, actually here, for faster pointer, we must actually write it like this. Faster is equal to faster dot next if we have faster dot next. And it means that if based on this while loop condition here and this condition that actually we define them here, we must have both faster and faster dot next in our linked list. But else our faster will become equal to faster dot next. So it will become like this, and our base condition is that if slower become equal to faster, and actually better I say that slower is not none somehow, yes, like this, we can return true, or if we don't meet this condition here, actually after while, we can return false here. So yes, this is the basic idea for solving this question here. If I check this here, as you can see here, yes, we actually accept all of the test cases here, and if we submit this code, so as you can see here, we beat 87% of other solution that we will use for this question here, and based on memory complexity, we hit 97% of other solution that people use. And if we want to analyze both of this approach here, from time complexity approach, we know that all we did in this question was that we iterate over our linked list here, so our time complexity will become equal to big O of n. And for a space complexity, we know that all we did was that we defined 2 variables here, a slower and faster, and in each step we update both of them. So our space complexity will become equal to big O of 1. And yes, this is the best and optimized solution for this question. I hope guys enjoyed this video, and You can use it in your university, in your exam, in your interview, or anywhere else. And I hope that it was a very actually useful and good video for you. You can check my GitHub profile for other question and solution that I use in my video and more. My GitHub profile name is ComTheory, like my actually YouTube channel, and you can check it there. And I hope guys enjoyed this video, and if you have any idea, leave them in the comment part. I will read all of your comments and opinion, and it is the biggest motive for me when I read your comments or opinion. This is very big motive actually. And if you like them, you can subscribe to my channel. And yes, that's it. Have a nice day guys. Goodbye.